Hello, this is Mr. Stansbury. I'm going to take you through the 11F assignment. Alright, so we'll start here with number 1. Convert the following 8.65 centimeters cubed to millimeters cubed. So, for these three, we're going to want to have our little conversion table thing up here. So the King Henry died unexpectedly drinking chocolate milk, right? So, we're going from centimeters to millimeters. So if here's centi, and then here's meters. So to convert once, we go over 2 times, right? So from centimeters to meters, you got to move the decimal twice. But again, since we have 3 dimensions of it, so it's cm cubed, then we have to convert 3 times. So 2 times 3 is we got to move the decimal over 6 spots to the left. So we start with 8.65. So we got to go 1, 2, 3, 4, 5, 6. So it's 0.00000865 would be our answer. All right. Same thing for this one here, millimeters to centimeters. So here's millimeters, here's centimeters. So we just got to go over once. But again, since it's volume, it's cubic, then we actually have to multiply that one conversion by 3. So we start 86,000. Decimal is here. We move over 1, 2, 3. So it just converts to 86 centimeters cubed. All right. So this is 0.00000865 millimeters cubed. Okay, and then this one here, centimeters cubed to meters cubed, which is just like the first one here. So to go from centimeters to meters, we got to move 2 to the left. And again, since it's 3 dimensions, we got to do that 3 times. So here's our 300,000. Starts here. We got to do it 6 times. 1, 2, 3, 4, 5, 6. So it's 0.3 meters cubed. Okay. All right. Moving on to number 2, 30,000 ingots of lead, each with volume 250 cubic centimeters, are required by a battery manufacturer. How many cubic meters of lead does the manufacturer need to purchase? So they want it in cubic meters. We're currently in cubic centimeters. So you can either convert at the beginning or convert at the end, and it really doesn't matter. So I think I'm just going to leave it, and then I'll convert my answer at the very end. So I'm going to leave it in centimeters cubed, right? So each one of these with volume of that required by our battery manufacturer. So it looks like we're multiplying those. So for A, we got 30,000 times 250 will give us our total number of cubic centimeters that we're going to need, right? And then once we do that, then we can just convert it at the end. Okay, so let's see. We got 30,000 times 250 gives us what? Let's see, 1, 2, 3, 7.5 million. Right? And then to go from centimeters cubed to cubic meters. Let's see, we have this. King Henry died unexpectedly drinking chocolate milk. Centimeters to meters, we got to go 2 to the left. So we're starting here, and we got to go 2 to the left, but it's cubic, so we got to do that 3 times. So 1, 2, 1, 2, 1, 2. So it should be 7.5 cubic meters. Okay, so let's move on to B. Manufacturer of lead sinkers for fishing has 0.237 cubic meters of lead. If each sinker is 5 cubic centimeters in volume, how many sinkers can be made? So, again, we're going to want to convert one or the other here. I'd rather deal with a bigger number than a little teeny decimal, so I'm going to convert this cubic meters of lead into cubic centimeters. So, 0.237 cubic meters is going to be how many cubic centimeters? So again, from centimeters to actually we're going from meters to centimeters, so we got to go 1, 2 to the right. But again, we got to do that 6 total times, because 2 times 3 is 6. So 1, 2, 1, 2, 1, 2. So we got 0, a 0, a 0. So we're at 237,000 cubic centimeters is 0.237 cubic meters. So each sinker is 5 centimeters cubed. How many can we make? So now we'll take that 237 and divide it by 5, right? So 237,000 divided by 5 gives us 47,400 sinkers. Right, 47.4, yep. Okay. Let's move on to the next one. Number 1, we're calculating the volume of these solids here. So we're going to want to figure out our what volume formula we're going to need. Okay, so we can use this volume of a uniform solid is the area of the end times the length. So basically what this uniform solid is like, if you'll notice here, we have a circle, and basically just take that circle and you move it through space, and it just ends up making this big can. So it's like a similar to a rectangular prism, but the end doesn't necessarily have to be a rectangle. It can be a circle or this blob looking thing here. Okay, so basically what we need to do is find the area of the end here and multiply it by the length or the height. Okay, so let's see, look, it even tells us what the area of the end is. So all we're going to do is take 42.8 square centimeters and multiply it by 8.9 centimeters and see what we get. Oops, 42.8 times 8.9 will give us 380.92. Okay, 380.92, and if you'll notice, we had centimeters squared and another centimeter, so that is centimeters cubed, which fits right in with volume, right? Because that's what we're figuring out. Okay, so this one here, same idea. Find the area of the length with the area of the base, which they already gave us, and then multiply it by how long or how tall it is. So let's just take 74.6. Oops, let's do this. 74.6 centimeters squared times 5 centimeters, and away we go. Okay, so 74.6 times 5 gives us 373 centimeters, 1, 2, 3 centimeters cubed. And again, it's volume, so that works. Okay. This one here, they don't give us the area of the base or the end, but they do give us what the radius is, and we know that the area of a circle is pi r squared. So what we need to do is just figure out pi r squared, because that's going to be the area of our end, and then multiply it by our height, right? By the height. So in this case here, we got pi times 8.2 squared times 13.9, and that's centimeters, and that's centimeters. Okay, so let's put that into our calculator, and away we go. So make sure you always hit the pi button instead of 3.14. It always gives you a little bit more accurate answer. Times 8.2 squared times 13.9. And that gives us 2936.2 we'll go with. And this is, again, that was centimeters, but it got squared, and then there's one more centimeter, so that's centimeters cubed for that one there. Okay, let's move on to the next one. Number 2, calculate at 3 significant figures the volume of these here. So now we have the volume of a cone here, so let's use that formula. Okay, so for the cone here, and I know that's not actually a cone, but as long as it's called a pyramid or a cone or something that tapers up to the top, it's always going to be this. It's 1/3 the area of the base times the height. So it's just like what we were doing before, but since it tapers up to a point, you have to take, it's only 1/3 of that instead of it was a uniform solid. Okay. So let's find the area of the base, which is going to be pi times the radius. Oh, actually, never mind. Look, they already gave us the area of the base. So we'll just use that. So that's just going to be 14.2 centimeters squared times 7.8 centimeters. And of course, it's just 1/3 of all that. Alright, so let's see what we get for that. So 1 divided by 3. I would definitely do 1 divided by 3 instead of 0.3, because 0.3 is going to definitely throw your answer way off. So do 1 divided by 3 times 14.2 times 7.8. And that gives us 36.92. And that is going to be centimeters. There's 2 of them there, 1 more here, centimeters cubed. I know the back of the book it's taking everything to 3 significant figures. So we could, if we wanted to stick with that, we would have 36.9 centimeters cubed instead. But this is just fine as well. Okay. Excuse me. Next one. Look, they already give us the area of the base. So we got 1/3 of 4.2 meters squared times 1.87 meters. Alright, so let's put that in. Oops, I'm going to turn it on first. 1 divided by 3 times 4.2 times 1.87 gives us 2.618. And that is going to be meters cubed. Okay, so here's our answers so far. Right, and then this last one here. Again, they're not giving us the area of the base, but they do give us the diameter. So that means that the radius is going to be half of that, which is not half of 18 is 9, half of 0.2 is 0.1. So we got 9.1 meters. So we can do area of the circle, which is pi r squared. So we do pi times 9.1 meters squared times our height, which is 21.6, and we got to take 1/3 of that. Alright, so 1 divided by 3 times pi times 9.1 squared times 21.6. 1873. It's 1873.1, so let's just go with 1873, and that's meters cubed on that one. Okay, let's move on to the next problem here. Okay, so number 3 here, find the formula for the volume of the following illustrated solids. So we're going to want to stick with our formula that we've been using over and over again, and that's to find the area of the base and then multiply it by the height. So area of the base here is going to be, let's see, if this whole thing is 2r, that means that just the radius part here will be half of that, so just r. Alright, so the area of the circle is going to be pi times radius, in this case is r squared, and then we got to end up multiplying that by the height, which is 4r. So it's really just going to be pi. Well, let's see, we've got 4 pi, so 4 times pi, and then we have r squared times r the first, which is r cubed. So there's the formula for the volume. So once we know what the r is, then we can figure out what the volume of the whole thing is. Alright, so this one here, we want to find the area of this semicircle here, and then multiply it by its height. So that's going to be half the area of a circle. So let's see, if this whole thing across here is 2x, that means that just the radius here of that circle would just be, the radius there would just be x. Okay, so that area is only going to be half of pi r squared, right? So pi r squared times the height, and in this case here our radius is just x, so it's pi times x squared times 4x, and really we can divide the whole thing by 2, but let's just do this. So let's see, we have 4 pi x cubed over 2, so that's just going to be 2 pi x cubed will be our volume for that one there. Okay? Alright, let's move on to the next one. And that's number 5. A concrete path 1 meter wide and 10 centimeters deep is placed around a circular lawn of diameter 20 meters. Draw a plan view of the situation. Okay, so concrete path 1 meter wide, 10 centimeters deep around a circular lawn. So here's our lawn, right? And then you've got this path that goes around the lawn, right? Let's see, and this is 1 meter wide. Let's see, this diameter here is 20 meters, so I'm just going to do this. That means that the radius is going to be 10 meters. This here is going to be 1 meter, and then the depth of this thing, if we're looking at it from the side here, you kind of get the idea. The depth is 10 centimeters. But again, look, we've got this is meters, and this is centimeters. So I want to convert that. So King Henry died unexpectedly drinking chocolate milk. So we're going from centimeters back to meters. So we got to move the decimal over twice. So that would mean 10 centimeters. Move it over twice, 0.1 meters. Now we've got everything in terms of meters. Okay. So let's see, here's our plan view, I guess. It's not a beautiful plan view, but you hopefully kind of get the idea here. Find the surface area of the concrete. So for B there, if we're finding the surface area, basically what we want to do is find, say here's the concrete, there's the grass part there. To figure that out, it's just going to be the area of the big circle minus the area of the smaller inner circle, right? So let's see, the area of the bigger outer circle is 10 meters plus another meters. This radius here is 11 meters, and this is just the inside, the grass part, that is just 10 meters. So area is pi times radius, which in this case is 11, pi r squared, right, minus this pi r is, in this case, is 10 squared. So we're just going to figure out what those are, subtract them from each other, and that should be the surface area of the concrete. Alright, so we've got pi times 11 squared gives us 380. Let's go with 380. And then the pi times 10 squared, pi times 10 squared gives us 314. All right, 314.15, yeah, we'll go with that. So when we take 380 minus 314, that's going to give us, let's see, 380 minus 314 gives us 66 meters, and we're talking about area here, right? Because that was 10 meters squared, that's 11 meters squared, so it's 66 meters squared. Should be the surface area of our concrete. Alright, so now find the volume of the concrete required to lay the path. So we've found the area essentially of the base. Now we just have to multiply it by the depth or the height, right? So for part C, we're just going to take 66 square meters and multiply it by 0.1 meters, and that's going to give us 6.6 cubic meters of concrete is what we need to use to lay the path. Alright? Okay. Moving on to number 9. Water supply department uses huge concrete pipes as such to drain stormwater away. What is the outside radius of the pipe? So let's see, if this whole thing is 1 meter here, and hopefully that would make sense that the radius is just going to be half of that, which would be 0.5 meters. So A is 0.5 meters. Okay, for B, it asks what's the inside radius of the pipe. So that's going to be that's basically going to be 0.5. That's from the inside to the outside, but then we got to subtract the 0.05 minus 0.05, which is going to give us 0.45 meters. Okay, and then part C, find the volume of concrete necessary to make one pipe. So what we're going to want to do there is find the volume of the entire pipe, as if there was no pipe, so that doesn't make any sense, but like the entire cylinder here, right, without the hole in it, and then what we need to do is subtract the volume of the hole out of that. So basically, it's, if we're looking at it from the top, this is what we've got. We've got our pipe here, so that's going to equal the volume of the big outside pipe, and then subtract the volume of the smaller inner pipe, right? So, but now we're not just talking about surface area, we're also talking about volume. So, volume of that is going to be the area of this circle times its height. So the area of this outer circle is this 0.5. So we got pi times 0.5 squared is the area of the base, and then we multiply it by 2.5 because that's the height, right? And then we're going to pull the middle part out of that, which is pi times 0.45 squared times 2.5, because that part's coming out. Okay, so let's calculate that. And just to make our life a little bit easier, I'm just going to enter this whole thing in instead of doing one. Let's just do one minus the other. That'll make it a little bit. That'll help it hopefully make a little bit more sense. Okay, so we've got pi times 0.5 squared times 2.5 gives us 1.9634. Let's go with 1.963, and then the other one is pi times 0.45 squared times 2.5, and that is 1.590 minus 1.590. So once we subtract those two from each other, so we'll do 1.963 minus 1.59 gives us 0.373, and that's going to be, everything's in meters, right? So meters, cubic meters. Okay, so that's how much, that's the volume of concrete necessary to make that one pipe. Okay, all right, moving on to the next one, number 11. Black plastic cylindrical water pipe is to have an internal diameter of 13 millimeters and walls of thickness 2 millimeters. 1,000 kilometers of piping is required for a watering project. Piping is made of bulk plastic, which weighs 2.3 tons per cubic meter. How many tons of black plastic are required for the project? Okay, so let's draw a picture of what the heck's going on here. Okay, so basically you've got this black pipe. Okay, it's just think of plastic PVC pipe. Okay, so if we're looking at this pipe here from the end, it's got an internal diameter of 13 millimeters, and then the external it's 2 millimeters thick. So basically you got this pipe that, I mean, it's forever long. It's 1,000 kilometers. That's a lot of piping. Okay, so if we take a little bit closer look at this pipe end here, so we'll say this is this right here. Here's what our pipe looks at if we're looking down through the pipe, right? And let's see, it's got an internal diameter of 13 millimeters, so here to here is 13 millimeters, and then it's got a 2 millimeter thickness, so this here is 2 millimeters. Okay, so we got to figure out, basically we got to figure out the volume of all of this plastic, right? So again, it's going to be just like what we've done on the past two problems. This pipe here is going to equal the volume of the entire big pipe, subtract the volume of the inner pipe, and away we go. Okay, so the problem is we got millimeters and kilometers, and then we have to convert it into tons. All right, so let's first off, let's just figure out the volume that we need. Okay, so that's this minus that. So this radius here of the big outer one, let's see, 13 divided by 2 is 6.5. So that's this one here, right? That's 6.5 millimeters. And then this one here is 6.5 plus 2 more, so that's going to be 8.5 millimeters. Right? Okay, so let's see, the area of the base is just going to be pi times 8.5 squared, but then we also have to multiply it by the height, or in this case the length here, right? So we have 1,000 kilometers. So King Henry died unexpectedly drinking chocolate milk, right? So we have right now we're at 1,000 kilometers, but we got to turn it into millimeters just so that we're working in the same thing here. So we got 1, 2, 3, 4, 5, 6. I'm going to move this decimal 6 spots to the right. 1, 2, 3, 4, 5, 6. So we have to multiply it by that height. So times, let's see, what is that? 1, 2, there's a comma there, there's a comma there. 1 billion times 1 billion. And then we got to subtract pi times 6.5 squared times 1 billion. Oops. Okay. Alright, so let's plug that into our calculator. Okay, here's the first one, and that e to the 11 means I'm going to move the decimal over 11 spots here. Okay. Okay, so instead of writing that all down, I'm just going to subtract this off here, and that gives us 9.424 blah 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 e to the 10th. Okay, so here's excuse me, here's the thing that's going to help us out here. We need to figure out how many cubic meters we have. Right now this is cubic, that's cubic millimeters. So let's do this. Let's go back and let's convert our millimeters. Okay, so let's get rid of this so that we can do our conversion a little easier. And so we're going from cubic millimeters back to meters. So we got to move it 1, 2, 3. But again, this is cubic, so we got to move it over 3 times. But we got to do that. We got to move over 3 spots 3 different times. So 3 times 3 is, we got to move the decimal back 9 total spots. Okay. Here's the great part about this. This says we got to move the decimal to the right 10. So we got to move it to the right 10, but then we got to move it back 9. So really we just have to move this decimal over here 1 spot. So it should be 94.24, let's call it 248. 94.248, and that is cubic meters of of plastic, right? So then let's see, the piping is made from bulk plastic which weighs 2.3 tons per cubic meter. So how many tons of black plastic are required for the project? So we got to multiply that by 2.3, or just take what we have here and multiply that by 2.3. Move the decimal over 1, and actually wait, e to the 11. So now we got to, since we had to move it back 9, move it forward 11 here, move it back 9. So actually got to move it over 2. So it'd be 216.77. We'll call it 216.77 TONNES tons. Okay, because that's metric tons. Whew, that's a doozy. All right, so you just got to really make sure you don't get. You got to make sure you do your conversions correctly. Otherwise, this answer is going to be way off. Okay. All right. Last one. Number 12. Find the sides of a cube of butter of volume 34.01 cubic centimeters. So, let's see the sides of a cube of butter. So the volume is just going to be, for that thing, the volume is going to be the length times the width times the height, because that's what volume of a cube would be, right? So each of those sides are all going to be the same. So we'll just say the volume is just the length cubed, right? But we know the volume is 34.01, so we go 34.01 is one of our sides cubed, so what we have to do then is just we have to get rid of that cube, so we have to cube root both of those sides here, and we get that our length is going to be, let's see, we got to do second. Actually, on this calculator here, we got to do math, and there's actually a cube root button here. So we did that, and we're going to do 34.01, and that gives us 3.24, we'll call it, for the length. 3.24, and this is centimeters. Okay? All right, for C, for D, the radius of a weather balloon has a volume of 73.62 meters cubed. So, a weather balloon, I know, does not look exactly like a sphere, but we just have to assume that it is a sphere. Okay, so let's pull up the sphere formula. This is our volume of a sphere. So they give us the volume, so we're going to put 73.62 equals 4/3 times pi times the radius cubed, and we're trying to figure out what the radius is, right? So we want to divide both sides by 4/3 and pi. And pi. Alright, so let's pull up our calculator and do that. So we got 73.62, and we're going to divide it by, and we want to divide by both 4/3 and pi, so I'm going to do parentheses, 4 divided by 3 times pi, and then close our parentheses, so then it makes sure we divide by everything we need to, and we get 17.575 equals r cubed. So we got to get rid of that by taking the cube root of both sides, right? So we will just now take the cube root of our answer, and we get 2.5999. So let's go with that the radius is 2.6, what is it? Let's go with 2.60 to show that we rounded a little bit farther, 2.60 meters for the radius for that one. Okay, let's see, E, radius of a steel cylinder of height 4.6 centimeters and volume 43.75 centimeters. So, volume of our cylinder is really just the area of the base of the cylinder times the height, right? So area of the base is going to be pi r squared. So we know that our, let's see, our volume. So we know that 43.75, our volume is going to equal pi times the radius, and that's what we're looking for. So we don't have that, pi r squared times the height, which is 4.6. Okay, so we want to get the r squared by itself, so we're going to divide by pi and 4.6, right? So divide by pi and 4.6. So with our calculator, we'll do 43.75. We're going to divide that by both pi and 4.6. So put those in parentheses. We got pi and 4.6. If you happen to put 4.375 divided by, without the parentheses, divided by pi times 4.6, it will take 43.75 divided by pi, and then it will multiply your answer by 4.6. So you'd end up doing the wrong operation there. So make sure you put it in parentheses if you're doing it all at once. Okay, that gives us 3.027 equals our radius squared. So we want to square root both sides and figure out what our radius is. So square root of our answer gives us 1.7399. So let's go with 1.74, and that's going to be centimeters, right? Yep, because that's what everything else is in. Okay. Okay, and then the last one is F. Radius of the base of a conical bin of height 6.2 meters and a volume of 203.9 meters cubed. So let's draw a picture just so we know what the heck's going on here. It's a little bit harder to kind of see in your head sometimes. So here's our cone. We're trying to figure out what is the, oops, I just said a little bit too far, what is our radius. But they do give us that the height here is 6.2. right? And we know that the total volume is 203.9 cubic meters. Okay, so if you'll remember, the volume of a cone is just 1/3 the base times the height. Okay, let's call that one up just for good measure. Okay, so here's our volume of a pyramid or cone, 1/3 of the area of the base. So our volume we already know is 203, so we got 203.9. And sorry, that's meters cubed up here, not just 209 cubed. Equals, let's see, 1/3, and then the area of our base is going to be pi r squared, and then times the height, which is 6.2. Okay, so we got to get the r squared by itself. So we want to get rid of the 1/3, the pi, and the 6.2, right, from both sides. Pi 6.2. Okay, so on our calculator, we got to do 203.9, and we're going to divide by parentheses. 1 divided by 3 times pi times 6.2, and close our parentheses, and that should give us the right answer. We get 31.405 equals our r squared, right? Because those are gone, and those are gone. So then we just square root to get our answer. So we square root our answer, and we get 5.604. 5.60, and this is meters. Should be our radius. Okay, that's all there is for 11F. So if you have any other questions, please feel free to ask. Thanks.